You're back at the RostyMaths channel, and this is a video all about parallel lines. Let's jump into it. Okay, so this is not the parallel lines that you're used to with all of your alternate and corresponding angles. This is parallel lines on a graph using y equals to mx plus c. Now, I've spoken about those in my other two videos, which you can see popping out the top there, or alternatively, check it in the description at the end of this one. But let's talk about what parallel lines are all about. So here I have got a graph with my y and my x-axis, and I have a line over there. Now that line, the equation of that line is y equals to mx plus c. And if you've watched my other videos, then you'll know that m represents the gradient of this line, tells you how steep it is, and the c is the y-intercept right there where the line cuts the y-axis. Now, I'm going to now quickly stick another line on here, and this line is meant to simulate a parallel line like that. And that brings us to our first point in this video. When you look at these two lines, they're leaning in exactly the same way. And we learned from my last video that lean tells you the rate at which it's going up. And that rate is going to be the same. So the main point of this video is that parallel lines have the same gradient. So whatever the gradient is of this line, it will be the exact same gradient here. So let's just make up a fictitious one. So let's say the equation of this line is y equals to 3x plus 2. Then the equation of my red line will be y equal to 3x, but it will be a different y-intercept. Let's say this is 2, this might be, I don't know, maybe 1 or minus 1, sorry, or minus a half, because it's quite a big gap there. So I'm going to average it as minus a half. So minus a half like that, and this is done. Now the main point of this, again, I'm going to stress it, what you need to look for is the gradient of the line when they are parallel. And when they're parallel, the gradient is the same. There is a 3 here. That means there's going to be a 3 here. The y-intercept can be different. It's not a problem. Okay, let's do a couple of questions just to reinforce the point and then bring the video to an end. All right, let's start with this question here. I have the equation of a line there. And the question is, write down the equation of another line that is parallel to this line. So the minute you see the word parallel, first thing to do, find out what the gradient is. So straight away, we know that from y equals mx plus c, that 3 is my gradient. So long as that remains the same, I am good. So we're just going to say, well, the equation of another line will be y equals to 3x plus whatever you feel like. You can even not put anything if you want, okay? But this is now finished. One last question to finish this short video then. Okay, so here is an exam question that we'll look at. So a straight line has equation 2y minus 10x is equal to 8. Work out the gradient of that line. Well, straight away you can see what the problem is there. It's not easy to spot the gradient, and the reason why it's not easy is because the line doesn't look like y equals to mx plus c. If it looks like that, then it would be easy to spot that gradient, but it doesn't look like that. So let's make it look like that first of all. So we're going to have 2y take away 10x is equal to 8. What I actually want is y to be on its own without anything else next to it. So the first thing we will do is we will remove that 10x. So we're going to remove that 10x by adding 10x to both sides. And when we add 10x to both sides, that will cancel straight away. This, by the way, this is a topic called rearranging formulae, or subject of the formulae. I have a video on this that you can check out. It's popping out in the pop-out banner, or it's in the link in the description down below. So you can check it out there. Anyway, so we're going to remove that. So once we remove that, we're now left with 2y on its own on this side and 8 plus 10x on the right side. We've still got a problem because there's a 2 next to that y. Remember, it needs to look like this, where y is by itself. So we're going to divide by that 2. So divide by 2, but you have to divide everything by 2. Okay, you can't just choose one thing and just go. Anyway, straight away, those 2's will cancel out, leaving you with y on its own. And then 8 divided by 2 is going to be 4, plus 10 divided by 2 is going to be 5. So that's going to be 5x there. Now it looks like that, sort of, but it looks like that. And it's really easy to see here that the gradient of the line is 5. So the answer to question A is that the gradient is equal to 5. This is done. Now we go to the last part and finish up this video. It says, write down the equation of the line that's parallel to this line. The minute I see the word parallel, I know that the gradient needs to be the same. So all I'm going to do for part B of the question is y equals to 5x plus, pick a number. I'm going to go for 6. You can put whatever number you like. So the only thing we're looking for is that the 5 is staying the same there. And this is done. One tiny little clue before I jump off the video today, and that is it says write down here. In a maths test or anything like that, if you see write down or state, usually the answer is already there or given to you. So please make sure you look out for things like that. All right, that brings us to the end of this video. I hope you understand now how parallel line works on the equation of a line. But for now though, until I see you on the next one, peace.